This is a help video for the final exam project review. All right, so this is question number 1. Assume the readings of a freezing on a bundle of thermometers are normally distributed with a mean of 0 degrees and a standard deviation of 1. So it has a standard normal curve, essentially, 0 in the middle, standard deviation of 1. A single thermometer is randomly selected and tested to find the probability of obtaining a reading greater than negative 2.306 would be here on the number line. Looking greater than that, we automatically know that this is going to be quite a bit bigger than 50%. Here's the 50% line. 1 standard deviation would be -1, 2 would be -2, so we know we're like 50 plus this large amount. So it's going to be like 0.99 something or 0.995. So let's find out exactly. And how do we do that? We're going to use the normal CDF function on our calculator to find that area. I'm going to choose normal CDF, which is under the second bars, which is the distribution key. Number 2. Lower limit is negative 2.306. Upper limit is one really big number. I just put a 1 with a whole bunch of zeros there is fine. Mean is 0. Put a really big number with as many zeros as you can handle. And then hit paste. This is 0.9894447. Right. Probably want to do that to 4 decimal places, so right here. Rounding down, so 0.9894. All right. Population has a normal distribution with 231.2 and a standard deviation of 47.7. You intend to draw a random sample of 64, which changes our standard deviation of the sampling distribution. We would divide by the square root of 64, so we divide both sides by 8, this by 8. Which would be okay. Find the probability of a single one. That means we use the standard deviation, and we're going to know that's greater than 229.4, greater. Again, we're covering more than half, so if we get a number that's less than 0.5, we know we did something wrong. So second, distributions. Number 2, normal CDF. Lower limit is 29.4. Upper limit is something huge. Our mean this time is this instead. Don't forget to change that. And our standard deviation is 47.7. Paste and hit enter. And like I said, it's got to be bigger than 0.5. It's just a little bit over. These are pretty close based on our large standard deviation. All right, now it says you now have a sample size of this. So we're going to run the same thing, but we're going to change our standard deviation from here to this standard deviation right here, because we are now talking about the sampling distribution and not just a single one. So second distribution, normal CDF, lower limit stays the same, upper limit stays the same. The mean stays the same because the mean of your samples always has the same sample mean of this population, but the standard deviation becomes or 5.9625, and we paste that, and now we get 0.61866307, right? So that is number 1 and number 4 are very similar in this case. All right, moving on. You work for a company that produces electronics with integrated circuits. One of your products is called a shift register. The product is designed to automatically shut down if the operating temperature exceeds 175 degrees. All right, so we're going to shut down at 175. We know the manufacturing has a standard deviation, a sigma of 0.4. You test 6 Now, you'll notice one of my problems is that this rounded to different decimals, and I didn't get them all. If you want to see all of your decimals on your calculator, you can go to your bars and then go down to number 5, which is statistics. And then you go all the way down past number 10, past A. Oh, sorry, you go over to tests first. And then you go all the way down past number 9, past 0, and then A, B, C. And go all the way down to the letter H. And that is lower. And if you hit enter twice, then it gives you all the decimals for the lower one. And if you go to letter I, you get the upper. Again, VARS number 5, statistics test upper, and it will give you all the decimals for the upper limit, so you can see all those decimals. All right, and the final one that was asked is number 19. This says, we wish to perform the following claim at a significance level of 0.05. So I'm going to stop here for a second. Just notice that this is a P, so this is a proportion test. And it's a one sample, a one prop z-test. And I know that already just because that's a P. And they're telling us to use the one prop z-test right here and not a binomial. You should not use for this test. Okay, so we obtain a sample of this size. There are 101 successes, and they don't want us to use continuity correction. That's fine. You should use normal distribution as an approximation for that. It's fine too. Basically just telling us to use this test on our calculator. The critical value, so we use like, what is the critical value for this test? Well, it's the same, it's a z-test, so it's a normal curve, so we use the same normal curve. All right, alpha is 5%, so that's 2.5 here. And this is a two-tailed test. Look right here, two-tailed. So we're gonna have area in both tails. Over here and over here. And each of those areas is gonna be 0.025. Looking for that cutoff, so I'm gonna go to inverse normal and choose my area as left 0.025. So second bars, distribution number 3, 0.025 for area, 0, 1, and left, and hit paste. And we get negative 1.95996. That goes over here. And you don't want the negative, just the number, because they already have that plus and minus there. And now they want your test statistic. So really easy way to do this is just go to one prop z on your calculator. So stats over to test, choose one prop z, which is number 5. It says P naught, right? That's from our H naught is 0.32. Successes, 101. N, 365. Not equal is our proposed, and calculate. That gives me my test statistic of negative 1.77. Now, this number is negative 1.96. Negative 1.77 is right here. It is not in my shaded area, so it is not in the critical region. I failed to reject the null. You never accept this one. That's always a red herring. And then it says, there is not sufficient sample evidence to support the claim that the population proportion is not equal to 0.03. This one right here. Cool. Well, I hope this is helpful. I'll go ahead and post this on YouTube, and everybody have a great night. Thanks. Bye.